In this video, we will multiply a binomial expression by another binomial using the distributive property. So let's take a look at what that looks like. Remember, a binomial is an expression with two terms. So x plus 2 is a binomial, and x plus 4 is a binomial. They're both in parentheses here, and we don't see the operation between them. It's implied that they're multiplying. So we're multiplying two binomials together. What this really means is that I'm taking everything in this first one and multiplying it by everything in this second one. So I have to make sure that every term gets distributed. So I take a look at the first term here is x. It's going to get distributed to that second binomial. So x is going to be multiplied by x plus 4. But I can't forget about this plus 2. It also needs to be distributed to the x plus 4. So now I can start here and distribute this x. X times x gives me x squared. X times 4 gives me 4x. And then I can also distribute this 2. 2 times x is 2x. 2 times 4 is 8. Then I notice in this expression that I can combine 4x and 2x together and get x squared plus 6x plus 8. I no longer have any more like terms to combine, and so I know I'm finished. This is my final expression. Notice that our answer is a trinomial. In this next example, we're distributing m plus 3 across m minus 7. So I'm going to be taking this first m and multiplying it times our m minus 7. So m times m will be m squared. M times negative 7 will be negative 7m. But I also have to distribute the positive 3. So positive 3 times m minus 7. So positive 3 times m becomes positive 3m. Positive 3 times negative 7 becomes a negative 21. I notice once again that those middle terms combine together to be m squared minus 4m minus 21. Here I'm distributing a w minus 2 across a w minus 3. So I take that first w and multiply it by w minus 3. That becomes w times w, which is w squared. W times a negative 3 is negative 3w. Now I also have to distribute a negative 2 across w minus 3. So I have negative 2 times w, which is a negative 2w. And I have negative 2 times a negative 3, which is a positive 6. Once again, I notice those middle terms can combine because they both have a w with the same exponent. So negative 3 minus 2 becomes a negative 5w. So my final expression is w squared minus 5w plus 6. The 3 on the right are on your own problems. Okay, next, you're seeing a binomial here that doesn't just look like x plus or minus a number. It can be any binomial that we distribute. So here I'm distributing 4x minus 7 across x plus 3. So I'm going to have 4x times x plus 3 and negative 7 times x plus 3. Distribute the 4x to the x plus 3 first. So we have got 4x squared plus 12x. Minus 7 times x plus 3, we get minus 7x minus 21. And we combine our middle two terms. Positive 12 and negative 7 become a positive 5x. In this next example, notice that we don't just have an x, we also have y terms in our binomials. And that's okay. It's just a binomial times a binomial. It's just distribution. So I'm distributing this 4x first across 7x minus 2y. So that becomes 4x times 7x, which is 28x squared. 4x times minus 2y becomes negative 8xy. Notice how I have both of those variables in that term. But I also have to distribute the y across 7x minus 2y. So I have positive y times 7x becomes a positive 7xy. Y times negative 2y becomes negative 2y squared. Notice that the negative 8xy and positive 7xy are like terms. They have the same variables and same exponents. So I can combine those terms. I can't combine anything else, and so my final expression is 28x squared minus xy minus 2y squared. These next two problems are on your own. Okay, next we have x plus 2 being distributed across x minus 2. So we have x times x minus 2, and then the 2 times the x minus 2. So x times x becomes x squared, x times negative 2 becomes negative 2x, plus 2 times x is 2x, 2 times negative 2 is negative 4. Notice what happens here in the middle on this one. We have a negative 2x plus 2x. Well, that's 0. So those middle two terms actually cancel away, and all we're left with is x squared minus 4. This right here actually has a special name. When that middle term cancels, this is called a difference of two squares. Difference because of the subtraction, and the squares because x squared and 4 are perfect squares. These other two problems are on your own. In these last two examples, I want you to really take a look at what's happening here. We have x plus 4 in parentheses squared. What this really means is we have x plus 4 times itself. That entire binomial is being squared. Notice how this is different from our power rule. Let's go ahead and simplify it and see if we would get anything different than just distributing the power. So we're going to be distributing this x across x plus 4. So multiplying x times x plus 4 here. Then our 4 times our x plus 4. So we have x squared plus 4x plus 4x plus 16. So we have our middle terms that would combine, and we would get x squared plus 8x plus 16. Notice that wouldn't be the same as just distributing the power and getting x squared plus 16. That's not the same. We have that middle term, so we can't forget it. So we have to rewrite this binomial squared as itself times itself.